morning, and today we are going to see the lecture number 40. Lecture number 40. Torques of a synchronous motor. Torques of a synchronous motor. Okay. So there are four types of torques are available. The torques of a synchronous motor will be classified into the torques will be classified into four types. Four types, namely the first one will be starting torque. Starting torque. Second one, running torque. Third one, pull in torque. Fourth one, pull out torque. Okay, so these are the four types of torques classified in synchronous motor. Okay, now we will see one by one. First one, starting torque. The other name of starting torque is known as starting torque is known as breakaway torque. Breakaway torque. Okay, so what does mean by a starting torque? It is the torque developed by the motor. Motor means synchronous motor. By the motor when full voltage, okay, when full voltage, that is 230 or 400 volt, full voltage is applied to stator winding, okay, which is applied to stator winding. In synchronous motor, stator winding is other name called as armature winding, okay, which is armature. So starting torque means it is a torque developed by the motor when full voltage is applied to the stator or armature winding. And Third point, the value, okay, its value may be as low as 10%. Okay, only 10 percentage. Its value will be low as 10 percentage, as in case of as in case of centrifugal pumps. Okay, if the value will be low, that is nothing but 10 percentage, and and if it will be high, okay, if it will be high, has 200 to 250% of full load torque. Full load torque, as in the case of loaded loaded two cylinder compressors. Okay, if it will be centrifugal pump, means the value will be low. Okay, the same thing is applicable for two cylinder compressors, means the torque value will be very high. Okay, in compressors the torque value will be very high, so the value will be around 200 to 250 percentage. So this is known as starting torque. And second one will be running torque. Second one, running torque. Running torque, as the name indicates, the torque developed by the motor under running condition. The torque developed by the motor under running condition. Okay, so here it is determined it is determined it is determined by horsepower. Horsepower means power rating. 1 horsepower, 746 watts or 756 watts horsepower. And speed of the driven machine. Speed of the machine driven machine. And the motor must have a maximum running torque which will be greater than this value. Okay, in order to avoid the stalling purposes. Okay, and in running torque, the value we have to maintain a maximum. Okay, based upon the specification. Okay, based upon the specification. That is the concept of running torque. And third one will be pull in torque. Third one will be pull in torque. A synchronous motor synchronous motor is started as induction motor till it runs 2 to 5% below the synchronous speed. Okay, below it synchronous speed. Then afterwards, 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 the excitation. The excitation means we are giving the DC excitation to the field winding. Okay, the excitation is switched on. The excitation is switched on. Okay, and once the excitation is switched on, and then rotor pulls PULL into step with with synchronously rotating magnetic field. Rotating magnetic field. And then the amount of torque, okay, the amount of torque at which amount of torque at which the motor will pull into step is called pull in torque. Okay, it's called pull in torque. And fourth one will be pull out torque. PULLOUT. Pull out torque. What is pull out torque? The maximum torque at which the motor can develop without pulling out of step or or synchronism or synchronism is called pull out torque. It's called pull out torque. Normally, when load of the motor is increased, that is normally when when load of motor increases, then the rotor tends to fall back in phase, okay, by some angle. Some angle means it should be the load angle. Load angle alpha. Load angle alpha, which will behind the synchronously resolving resolving means it is rotating, resolving stator magnetic field. Stator magnetic field, though it keeps running synchronously. Keeps running synchronously. So during this time, the motor develop maximum torque when its rotor is retarded by an angle of 90 degree. When rotor is retarded means a pull out, retarded by an angle, because angle which I already mentioned, it is a load angle. How much it is? It angle of 90 degree. Angle of 90 degree. In other words, I can mention, when the motor develops a maximum torque, the rotor can be shifted backward by a distance equal to half the distance between the adjacent poles. Okay, so during this time, the machine will start vibrating it, and if your load will be keeps on increasing it, okay, load will be increasing, increasing, it will cause the motor to cause the motor to pull out, okay, pull out of step, pull out of step, and then finally it will be stop the machine. Okay, so this is the purpose of the pull out torque. So the torques of a synchronous motor is broadly classified into four types. One is starting torque, second one is running torque, third one is pulling torque, fourth one is pull out torque. Starting torque means the torque developed by the motor when a full voltage, okay, that is if you apply the voltage, full voltage to the armature winding, then the starting torque will be produced. Okay, that is nothing but starting torque. The other name of starting torque will be a breakdown torque. Okay, and running torque means the torque developed by the motor during running condition. That is when the rotor starts running it, at that time we have to measure the torque. That is nothing but running torque. Pulling torque, if the motor at the starting stage, if the motor will be driven less than synchronous speed. Okay, now anyway our synchronous motor will be a constant speed. You have to run at constant speed. So during that time, because now the machine is running very much lesser than synchronous speed, maybe 2 to 4% or 5%. Okay, so during the time you have to make the motor to run synchronous speed 1500 rpm. At that time what you have to do, we have to apply a field excitation, okay, to a field winding. Okay, so this field excitation, if you switch on it, then the rotor will get into step by step, it will be get into the rotating magnetic field, then the machine will be running in constant speed. That is nothing but pulling torque. And pull out torque means the maximum torque at which the motor can develop without pulling out of step. Okay, so here in pull out torque the angle will be delay. That's fine, sir. They should stop taking schemes. The angle will be delayed. The how much angle it will be delaying means it is 90 degree, because you know the angle. Okay, actually what is the angle? It is, this is the V, this is V, and this one will be a EP, and this is IA. Okay, so load angle means this is the load angle. Okay, this load angle will be, it will be coming like this. Okay, it is 90 degree, it comes 90 degree. Okay, load angle, this one is load angle 90 degree. Okay, so now it will be comes at a load angle 90 degree, then the machine will be stop. Okay, how the machine will start, it's mainly depends upon the load. Understand my point? Understand? Any doubts? Any doubts? One question also not changed. You know the torque equation? Torque equal to 9.55 mechanical power developed Pm by synchronous speed. Unit is Newton meter. Okay. Any doubts? Any doubts, students?